When we're trying to find the intervals of concavity and the inflection points for any function f of x, we're going to follow the procedure on this slide. Note this procedure is very similar to the procedure that we used for finding the intervals of increase and decrease and the critical points. So the first step in this procedure is we're going to differentiate the function twice, and we're going to get the second derivative f double prime of x. Then we're going to find all the x values where the second derivative is 0, and find all the x values where the second derivative is undefined. These x values are your possible inflection points. We use these possible inflection points to divide the x-axis up into intervals. Once you've got these intervals, we're going to pick a test point in each interval, and we're going to plug it into the second derivative. We're going to see if the second derivative is positive or if it's negative on that interval. If the second derivative is positive, we have an interval where the function is concave up. If the second derivative is negative, we have an interval where the function is concave down. Now the last step is to actually find the inflection points. So we're going to look for any x values where the concavity changes. If it does, we're going to find the corresponding y value to locate the corresponding inflection point. Note again, just as with critical points, if there's no y value, there is no inflection point. So example 2 is going to be one example of applying this procedure to find the intervals of concavity and the inflection points of a function. Here the function is f of x equals 2x to the 6th minus 5x to the 4th. So the first step is to find the first derivative. F prime of x equals 12x to the 5th minus 20x cubed. Then we're going to find the second derivative. There, 5 times 12 gives you 60x to the 4th minus 60x squared. Now I'm going to factor this, just make it easier to solve. So I get 60x squared times x squared minus 1. Now I want to ask basically, when is this thing 0, when is it undefined? Well, the first thing to mention is the second derivative here is never undefined. It's a polynomial function. It has domain all real numbers. Now we want to ask when it's 0. Well, basically there's going to be two situations when it's 0. Either 60x squared equals 0, which means x equals 0, or x squared minus 1 equals 0, which means x is plus or minus 1. So these are our possible inflection points: 0, positive 1, and negative 1. So I'm going to put a 0 here, negative 1 here, and positive 1 here, and I'm going to form our intervals. The first interval is going to be from negative infinity to negative 1. Next one's going to be from negative 1 to 0. Next one's going to be from 0 to 1. And last one's going to be from 1 to infinity. I'm going to take a test point in each interval. Here we'll have negative 2. Here we'll have negative 1/2. Here I'll have 1/2. And here I'll have 2. So now I've got to figure out what does the second derivative do at each point. Well, here I'm going to have 60 times negative number squared. Negative 2 squared minus 1 is 3, which is a positive number. Negative number squared is positive. Positive times positive gives me a positive result. If I put in negative 1/2, I'm still going to have 60 times a negative number squared. Negative 1/2 squared minus 1 actually turns out to be negative in this case. Negative squared is positive. Positive times negative gives me a negative result. If I plug in 1/2, I'm going to have 60 times 1/2 is a positive number squared. 1/2 squared minus 1 is going to be a negative result. Positive number squared is positive times negative gives me negative. If I plug in 2, I'm going to have 60 times a positive number squared. 2 squared is 4. 4 minus 1 is 3, which is positive. Positive times positive gives me a positive result. So this first interval, negative infinity to negative 1, it's concave up. From negative 1 to 0, it's concave down. And from 0 to 1, it's concave down. And from 1 to infinity, it's concave up. So we have two inflection points. We have two places where the concavity changes. Here and here. There's no inflection point at 0 because it's concave down on both sides. So if I want to write out what my inflection points are, I've got to plug those two x values in and find the corresponding y values. So I plug in negative 1. Negative 1 to the 6th will be 1, so I have 2 minus negative 1 to the 4th will be 1, so 2 minus 5 is negative 3. If I plug in positive 1, 1 to the 6th is 1, so I've got 2 minus 5 times 1 to the 4th, so I've got 2 minus 5, which is also negative 3. So I have 1 comma negative 3. Those are my two inflection points.